That's pretty much going to just simply be maintained. Does that make sense? Okay. Fibrocartilage, which is what we see between the vertebra, the pubic symphysis. Fibrocartilage will be doing the same thing. As we're growing and developing, it will do the same thing. And once we've reached our full growth, the blasts are now stuck in their matrix, and they are sites. The one thing about cartilage, there's no blood supply, all right? Which is the reason that damage to these areas, such as this, the healing, if it occurs, takes a very long time. And in some cases, it doesn't. Okay? So cartilage, the chondroblasts form the matrix. Once it's done and the cells are stuck, they're now mature chondrocytes, and they reside in their lacuna. So what you would find is you would see like a little circle, and inside of it, the cell. Does that make sense? That cell is very much alive. That cell's job is maintenance. It needs to get nutrients. It needs to get rid of waste. So it is a very much alive cell. So in the matrix of cartilage, you will find some fibers, and one of those fibers you will find is the tough collagen. Now, in the case of cartilage, which of course is not showing right here, okay, but in your nose, okay, the portion that would extend from the bone to form the rest of the nose, this would be elastic, okay, so that it's movable, all right. When you look at the ears, all right, the little flap is elastic, okay, but that's still cartilage. Even though it's not showing, but for the trachea, okay, we've got cartilage in the trachea, all right. So in our osseous that we're going to deal with, we're going to deal with a lot of this costal and the fibro, okay, and tough collagen fibers are present. And what that allows for, especially in areas that have to deal, for example, with weight bearing, okay, we've got the femur, all right, we've got the tibia, the fibula, okay, and this structure that has to do this all the time and be under so much weight, okay, we've got really nice tough cartilage there also, the menisci, all right, so cartilage, pretty important. Now, something that we find in cartilage, pretty much everything about our body has 3 connective tissue wrappings, all right? And if we think about cartilage, if we're creating an area of cartilage, think about this hard fibrocartilage right here, okay? There will be a wrapping around it, And anytime we have a wrapping around, that is the term peri. Okay? And because we're in cartilage, chondro, okay? So I've got the chondro, okay? This is the perichondrium. What that has, okay? There are two portions to it, an inner and an outer. The inner portion, okay, the inner portion is delicate, not quite as many fibers, but it contains chondroblasts. That means the cell that can give rise to is located right here to the portion from a piece of cartilage. Does that make sense?
So like the perichondrium releases the blasts?
This is where we are going to have our source of the blast. But why? Am I born with this cartilage the size it is right here on this full? No, Whitney, I'm not. What has to happen from the time I'm born to now? And that means the bones are going to grow. Cartilage is going to grow. Cartilage is going to grow. So having the perichondrium, because what does the outer portion of the perichondrium have? This is my outer portion. What does it say the outer portion has?
Blood vessels.
Blood vessels. If I have a blood supply, I have access to the materials needed for these cells to do their job, which means it will allow for growth. Once I've reached my full size, the only thing now is that those cells are stuck in the matrix. The blood supply still remains though, but it's to that outer portion. So there is no direct blood supply into the matrix itself. But that structure has access. So if the cell is alive right here, but access is over here, how does my cartilage stuck between a bone, how does my cartilage get materials and get rid of waste? Movement. Anytime you are doing movement with these joints of your body, it's squishing stuff. And by squishing, you push materials out, you pull materials in, and you are nourishing your cartilage. The reason, therefore, they tell somebody old like me, get up and move. Take a walk. I do. Keep your blood flowing. Because the squish, okay, helps to nourish that cartilage.
What about like cartilage that wouldn't really move that much?
Such as what?
Like your ears, your nose.
They're getting the blood supply more. Plus, that cartilage continues to grow. I was looking at my nose this morning in the mirror, and I go, I can see why people get a nose job. All right? And yeah, the ears will get more flappy and bigger as we get older because it continues to grow. And that's the cartilage that doesn't stop growing, the elastic. So, the perichondrium is the nutrient source for the cartilage. The other, another type of cartilage is articular. When two things come together to work, they articulate. Bones articulate. One of the things that they're trying to represent on the model right here, they're trying to show with this blue part, okay, they're trying to show the articular cartilage. With articular cartilage, believe it or not, that is the cartilage that is most important between two bones. Yes, we can see that this cartilage, like the tough cartilage, okay, the meniscus, they can be removed, they can be, so they can have surgery done on them, blah, blah, blah. When the articular cartilage breaks down, okay, this is when pain sets in, a lot of arthritis, that sort of thing. And with articular cartilage, whatever you get from birth is all you got, okay? You don't get to have more of it. And one of the things, like when I had my knee surgery, when I had the meniscus surgery done, my doctor, he was, well, he's just like terrific anyway, and he stays up on all the research. He like works with other doctors in like the European countries, Israel, all these other places that are really doing lots of research and everything. So when he went in to do the meniscus surgery, he actually harvested some of my cells for the articular cartilage, and they were sent to a lab to be grown. So when I need that to be put back into my knee, I can't, so that it can actually grow more cartilage. So there are so many things now that they're doing with cells of the knee. Like, for example, a neighbor of mine goes in Wednesday to do his knee replacement surgery. Now, my mom, when she had her knee replacement done, she had both of them done on the same day. And that's when, they go in and everything's being done by hand, by the doctor. His surgery is going to be done by a robot. Well, y'all know me, right? Okay, I go, can you ask your doctor if I can come watch the surgery? And he said, well, I'll ask, but the doctor's not going to let me come watch. So anyway, but I'm like so amazed at this. I want to see this, all right? And it's being done by a robot. I can't wait to, to see what happens, because to me that's just mind-boggling.